Day 30. Okay. Disable preview. So where are we at here? I think, yeah. Okay, so that's supposed to be 5 pixels. And, well, is it? I think it is. Right. Where is the canvas size? Yeah, 5 pixels. Yeah, so it's being scaled up appropriately by the looks of it, because this is 12 pixels, right? This sprite. Yeah. Alright, now I just need to finish the code that puts these things into arrays of polygons and stuff. Which is here. Okay, well... well, what are we doing? We have one array. We need more arrays than that, but we have one array. And I suppose the next step is to pull this array out of the earth. As opposed to just like... as opposed to having all the points be a part of the same polygon, we actually need to determine what points are in what polygons. And I think this loop is set up to do that just fine. So really, we can just do struct what v2 array pointer i32 length capacity collision polys capacity. I mean, it doesn't really matter because we can always just change this. Yeah, so that's collision polys. Okay, so now we just, oh my god, what? There we go. I just allocate it, and it's meant to be this thing. It's a v2 array pointer. No, not a v2 array pointer. Okay, so now that we have that, so it's an empty array. Now, at what point do we switch between the polygons? Well, so we go in, so each loop is a file, so a stage. Then we go through this stuff to figure out this collision canvas thing. Yeah, so all of this is to figure out essentially the collision canvas. That's the debug code. Okay, then we go in here, we got, and we start searching the canvas. I see. Break shape walk. Okay, so this does seem promising. Yeah, this loop. This loop starts at the first corner and it doesn't terminate until we walk around the whole collision shape. So at the end of this, we have a collision polygon. So all we gotta do then is to just say, well, v2 array collision polygon is, well, the pointer should point to collision pointer plus collision points length. Because collision points, I think I'm only pushing into that here and nowhere else. Right, so this is actually the start of the collision polygon. And then at the end, we can figure out what the length is. I mean, well, I mean, I suppose I can just store it here, like I32, collision, point, length before shape walk is collision, point, length. Okay, just take a snapshot. And once we are done, we can say collision, poly, length is length after minus length before. So it's current length minus that length. Well, okay, and now that we have it, we can just rpush collision polys collision poly, just like that. Okay, let's see what that does. Okay, looks like we still have what we need to have here. Okay, well there it is. There's the one collision shape. The one and only one collision shape. Of course, we do need to add more collision shapes in order to debug this properly. So let's do that. Actually, are we even set up to walk around collision shapes that are not the outline? I mean, I guess we can start off by just adding something to the outline. Where's my ace sprite? So, brush, well, let's add it here. Okay, so if I just... Okay, there we go. So we are sorting somewhere. Apparently here. Ah, that's right. Get corner info. Next direction. Alright, pixel. Alright. I haven't quite implemented this stuff. So, if it's a bottom right corner and pixel is filled, so like well, okay, bottom right. And where are we asserting? So yeah, so that's corner, that's bottom right, and pixel is filled. Yeah, so, well, we're actually seeing bottom left first. Apparently. If we start here, then we go down, presumably. So we should be able to see top right. Oh, it's this one, right? Yeah, because it's that, and then we go here, and boom, there is a corner, and it's bottom left, and we have filled. Yeah. So the next direction, result, next direction, y. Well, actually, that's an interesting question. So in this case, we do go down. But is that like true in general? I mean, yeah, I think maybe actually yes. Huh. Well, go down. Wait, actually, go down means that. Like this is what's looking at the wrong thing here. Yeah, go down means positive y. because we're in pixel space here. Alright, so bottom left corner. So bottom left corner, that's like this. Wait, is it? It's like this if it's not filled, and it's like this if it is filled. And do we... I mean, in this case we go down from here, but like, is that always the case? Is that always the case, or is that only the case here? I mean, the way things are, well, like, you must go left here, because if you go down, then the wall normal will be pointing the other way. Like here, if you go down, yeah, so there is only one correct direction to go, which is down. So next dir y is 1 for bottom left. Okay, what about this corner? This is going to be top left, bottom left. So for this corner, okay, well, actually, let's see which one it is. Yeah. So next one is top left and filled. So we go left. Result next dir x equals -1. Okay, so are we gonna see the others? No. Okay, interesting. So we just see those two. Well, what do we get out of that? Okay, well, it does seem to be kind of following the shape there. Of course, it's not big enough. Maybe I should just make it bigger. Let's do that. Sprite size, let's make it 50 pixels. Wait, no, not sprite, canvas size. I want canvas size. Yeah, and we're gonna trim everything outside. Well, at 50, please. Trim canvas size, yeah, 50. Okay, oh boy. Okay, well, first of all, if there is nothing in it, like nothing, right? Nothing in it. Let's see if that works. But hold on, I need to recompile. See if that works. Okay, that does seem like the correct thing. And now that I got in here, I can't get out. Yeah, that actually is intended. Yeah, that's how it's supposed to work. And now, if I carve out a little corner here, it's like, oh my god, that's like that, let's say. Then, well, this should be its own collision, actually, shouldn't it? Can I fill this? Is there a fill tool? No? I mean, I guess I could fill it like that. Okay, because I don't know if I want to have to worry about that. Okay, so if I carve that out, save, compile, let's see. Okay, that compiles. Alright, so, okay, so if we're in here, okay, that does seem to be doing the right thing. Yeah, okay, I think so. I think so. Okay, well, now let's just do one of those here. let's see. All right, what? Okay, there we go. We have an assertion failure. So we found at a top right corner, and we have filled. We should go up. Up means -1. And then we should also find the top left corner. I mean bottom right corner. So bottom right corner means we need to go right. Okay. Let's get in there. Alright, so that, yeah, there you go. So this is the one collision polygon that's pulled out of the art. Okay, so that part is working. What if I add a collision shape inside? Does that work? Maybe. Or maybe not. Oh, well, actually. So now we have two polygons, which is correct. What's not correct though is that we're not actually iterating through all of them in the actual game. I'm only colliding with just the one. Go through all the polygons. Okay, well that's just another loop, isn't it? For something. For what? V2, well no, it's stage collision polygons, V2 array, was it like I64 I guess? The poly index is 0, poly index is less than stage collision polygons length, poly index plus V2 array collision polygon is that poly index. Okay, and then everything, all of this is in here. Well, actually, not even just that. It's also all of that. So the V2 array, excuse me. I think that makes sense. So collided. Wait, no, this part. No, this part is outside. It's here. Or, yeah. Because we need to find the nearest collision. So we need basically these three things are the point of the loop. We find the nearest collision, then we handle that. And then we do it again. Because we might not have accounted for all the movement that needs to happen. Of course, okay, so now I think we are going to collide with this thing. We can't see it though because I'm not drawing it. Anyway, I really need to improve my collision wall drawing. Collision wall drawing. Maybe I'll just do that. Well, it's here. Temp code to draw collision lines. Yeah. Well, you know, once you get the collision line, it's like all of this, basically, all of this is do I just wrap that in an iterator to just get collision lines? I mean, maybe. Because again, I kind of do the same thing here, just instead of doing it this way, we go into a loop. All of this is in here. Collision polygon is just that. Yeah. Now we can see the other collision shape. Okay, so for a stage, this is how it's gonna work. Just everything that's in there is pulled out. Just fine. And I guess while we're here, we might as well finish this off. So stages. Stages pointers, arena, alloc array, arena v2 array, collision, stages, capacity. And well, each file is one of those, so so we just do the same thing. So the relevant thing here is this array push into collision polygons, which only happens inside this loop. So we just go in and say, well, v2 array stage is pointer is stages, pointer plus stages length. Well, actually not stages pointer, hold on. It's collision polys pointer plus collision polys length. That's what it is. And we just save I64 collision polys length before is what? Collision polys length. And we go down to outside the loop. And at the end of this, we just go stage length is collision polys length, it's current length, minus collision polys length before. And then R push stages stage. Of course, this is just the collision for the stages, it's not anything else. Yeah, so that part works. Of course, we kind of do need a couple of stages to make sure it actually works. Well, I mean, I guess I might as well do that. Aseprite file new. Now let's do I don't know, 100 by 100 RGBA, transparent, square pixels. Yes, save as stage 1, 2, let's say. Save, and then just like put some collision shape in here, and then, well, it should probably still work. And if we go to generate it, oh god, if we go to generate it, we should see that we now have 2 stages. Alright, yeah. And then it should be, we can't switch between them. Except manually. Except manually. Get collision polygons from the correct stage. Yeah, well... And of course we have the stamp code to draw them where the same thing happens. Okay, so that's the other stage. Well, I mean, it is working in terms of just pulling out the art. Pulling out the collision from the art. So that, I don't know. That's good. Well, in that case, nothing else really needs to be done here. Get collision polygons from the correct stage. Yeah, that's kind of the next thing to do. Are there any obvious issues while we're here? Not that I can tell. We seem to be colliding correctly. Well, in that case, let's just commit this. Focus into primary sidebar. Yeah, that's fine. Yeah, that's what I did. Yeah, that's also... That makes sense, that makes sense. The to-do should go... Yeah, the to-do has gone away. So we have more points, more polygons, and more stages. And yeah, this code has changed appropriately. We are now going through all the polygons. Yeah, the stamp code is still... Yeah, let's switch back to stage 1. Yeah. Yeah, that's what it is. Okay. That's fine. That's fine. and the actual art changed as well. Okay, so pull all collision shapes from art. Yeah, I mean, I guess the next step would be to do, would be more to do with the actual game and not the art processing. Okay, do we have any to-dos here? The double corners, which we're not handling, and an offset for the sprites that's not in the top left. Yeah. That's for animation alignment. I mean, yeah, these two to-dos, so far it's not clear that we need either to support either of those things, so I'm just gonna leave them. So yeah, the next steps are all here in the game, where we need to keep track of what stage we're in and load the appropriate collision. Well, we also need to load the actual art for the stages and display that instead of these collision lines. But even if I do display the art, I will still want to display collision lines separately. So that will have to be implemented somehow. Anyway, but that's for another time. I don't really want to do anything else today. So thanks everyone. See you later.